So high sample concentration is one of the factors that causes deviation from Beer Lambert law. Generally, Beer Lambert law holds for dilute solutions. Beer Lambert laws only holds for dilute solutions. So once there is high concentration, then there is going to be close proximity between the molecules, and this will influence the electronic properties, which on the long run leads to deviation. So instead of you obtaining a straight line graph, you are going to have deviation. Maybe the straight line does not passes through the center. Also, remember that epsilon depends on the concentration of the compound. That is the constant in that Beer Lambert law expression. It depends on the concentration of the compound, and therefore once at high concentration, there is going to be it will result in deviation from linearity. Deviation, instead of you having a linear relationship, you will not obtain a linear relationship. So at lower concentrations, the epsilon can practically assumed to be a constant. So when you operate your solution at low concentration or lower concentrations, the constant in the expression we attain or assumed to be a constant. But at higher concentration, that means there is going to be deviation. The relationship will not be linear. Another factor that causes deviation is chemical reactions. If you have a side reaction or you have other molecules that undergoes chemical reactions, then there's going to be deviation from linearity. There is going to be deviation from Beer Lambert law. That is, you have other side reactions apart from the major reaction. The major samples, you have other reacting species reacting together as either unreacted molecules or reacted, other impurities reacting in your sample vessel. Then they too can lead to deviation. Also, change in color, change in pH can all lead to deviation from Beer Lambert law. Another major factor that causes deviation from Beer Lambert law is instrumental factor. Instrumental factor can occur. Probably you have your sample cell that is damaged. You have we call it unmatched sample cell, or instead of you operating using a monochromatic light, you have other intruding lights, or you have polychromatic radiation. All these can lead to deviation from linearity between your absorbance and concentration. And that is this is bringing us to the end of slide 1 of chemistry 318, spectrometric techniques. Don't forget to drop your comments, your questions, your queries in the comment section. I assure you they will be duly attended to. Thank you, and see you again. Bye for now.